Welcome everyone. This is the first video for my Middle School Math 1 class. So for this video, I'm going to explain a little bit how notes are going to work in this class and what to expect so that any parents or students or other interested people following along at home kind of get an idea of what to expect from your students' work. So up here we have our block day. So this is the first block day of school, and this is going to be lesson 1-1. So the title of the lesson is Adding Integers with the Same Sign. We're always going to have something called an essential question. Now, essential question, I call it like this is the goal of the lesson. This is what students should be able to answer by the end of the day. And I'd say it's usually going to be like a word type problem or something a little bit more challenging. And maybe they can do it at the start of the day, but usually they're not going to be able to. And by the end, I hope that they get comfortable answering something like this. Because this is the kind of stuff they should expect with the Common Core. It's not just adding or subtracting integers. It's looking at a problem like this and being able to figure out what it's asking and how to do the math, what math it's asking to do, and how to actually do this. So writing this down, there's going to be a left-hand column here. So this is what I want all my students to do. When they go home and review their notes, and they need to do this after every block day, I think this is a good part of practice. They're going to be writing their questions and comments. So basically they've maybe had a little time off. As they look through the notes, what does it make sense to them? What did they forget? Some things maybe it wasn't clear in class, or they didn't write down good notes, or they can't read what they wrote down. So this is where they write questions so next day in class I can answer this. Up here, somewhere on this page, I want some adult or responsible person to sign it off. And this is basically, I want students to be able to talk about what they did with maybe a parent or the relative or a brother or sister and someone else that's signing off. Because if they have to explain it to you, and if they can't, then they know where the problem is. And if they can, that means, hey, they probably learned something. So that's what I want you to do. Write any questions or comments on the left here. We'll go over those in class. Answering the essential question, let's go. So this is not everything that happens in class, but I'm kind of getting enough of the basics that I can in this video that hopefully you understand what we did. So the essential question was, Julio was playing a trivia game. On his first term, he lost 100 points. On his second term, he lost 75 points. And on his third term, he lost 85 points. Write a sum of three negative integers that models the change to Julio's score after the first three turns. So we're not answering this right away. We're thinking about, we call this the guess system. They use this in a few of the science classes too, and I think this is a good way. The guess is an acronym, and the G stands for given. So guess is G-U-E-S-S. Given. What do you know about the equation? So we talk and say, hey, what parts do we know? And usually it comes down to numbers that you know, and that. So you write those down. Unknown, like what are you trying to find? What you're trying to solve here? So what you're trying to solve is usually the question that, usually the last sentence, usually the sentence with the question mark. So in this case, hey, it's writing the sum. So last sentence will usually do it. Equations, so which math equations or tools we'll use. So sometimes there's a formula to use, but that's not so much for our class, but in physics they might. But like what kind of math subjects? Maybe you're talking about adding and subtracting numbers. So you might want to write that down. Like what do you think you're going to have to do in this problem? Sometimes you might multiply or divide or do fractions and stuff. So what tools are we going to have to use? Substitute, so I'm going to call this setting up the math. So, okay, let's set up our equation to solve this and then to actually solve the problem. All right, so we'll get back to this later. So I like to break down the topics we're learning. This is about adding negative integers. So we look at what your kid did. They should have filled out like we call this a circle map in this class, and what they actually know about integers. Now I want to model this in a few ways. So we're going to start with the basics, 3 plus 4. So a lot of kids can do this, and they should be able to do this, 3 plus 4, and say it equals 7. Now, you learn that, maybe learn how to do it just with the numbers, and you're fine. But I also want to model this in a few different ways. So one way we can model a 3 plus 4 is through chips. So they call them flip chips. So I'm going to model a 3 plus 4 this way. A 3 is just pulling out 3 chips. So that's your 3. And then when you add 4, you're going to pull out 4 more chips, like this. So adding those up, how many chips do you have? Well, you have 1, 2, 3, 4, 5, 6, 7. So your answer is 7. This is just another way to model this 3 plus 4. We can also do this with number lines. I'm going to do a vertical and a horizontal number line, and I got these reversed. Vertical and horizontal number line. So let's do it with the horizontal number line. This is what you usually see. So you put 0 in the middle, and maybe go 1, 2, 3, 4, 5, 6, 7, so on. So what you do in a horizontal number line is you always start at 0, and you first start adding 3, so you move up 1, 2, 3. So this is 3. Gets you right here. And then if you're adding 4, you move up another 4 and go 1, 2, 3, 4. And hey, you end up, your answer is 7. Now, I can also do this as a vertical number line. Sometimes this is nicer to see like positives go up, negatives go down. So if I start at 0, and I'm going to go up 3, I'll do this in red. Let's do this in red. So you're going to go up 3, 1, 2, 3. So 1, 2, 3. That gets you right there. And now I'm going to add my 4. So it's going to start here and go up 1, 2, 3, 4. So to 4, 5, 6, and 7. So this was adding the 4, and this one was adding the 3. And where do you end up? You end up at 7 as your answer. So these are just different ways to get the answer or to visualize what 3 plus 4 is. Now, what if it's negative numbers? Since they're both negative numbers work very similar, but instead of having positive chips, I'm going to have negative chips. So we're going to represent negatives as red. So to do negative 3 plus negative 4, when you say plus, you're going to add them together. So negative 3, I'm going to pull out 3 negative chips. And we're going to pull out 4 negative chips for over here. Well, how many total negative chips do we have? Count that up. You go 1, 2, 3, 4, 5, 6, 7. 7 total negative chips. That adds up to negative 7, since they are the negative chips. I can also do this on a number line. So if I put 0 here, when you have this minus 3 or negative 3, instead of going to the right and adding 3, you're going to go to the left 3 times. 1, 2, 3. So negative 1, negative 2, negative 3. That's where you're going to end up with negative 3. Now if I want to do the minus 4, I'm going to go 1, 2, 3, 4. It's negative 4, negative 5, negative 6, negative 7. That moves it down 4, and where do I end up? I end up at negative 7. Horizontal number line is going to work very similar. So going down 3 to 3, that takes you to negative 3. And then you can go down 4, 1, 2, 3, 4 to negative 7. That's negative 4. And so your total is negative 7. Or if you just do the numbers, that adds to negative 7. All right, I'm going to represent this differently. So we have kind of a word problem here. A temperature was 2 degrees Fahrenheit below 0. The temperature drops by 5 degrees Fahrenheit. What is the temperature now? So I'm going to break down this problem. I have the thermometer over here. Let's do part A. What is the initial temperature written as an integer? So when I say initial temperature, it's 2 degrees below 0. That means 2 degrees down. That's going to actually be at negative 2. And then I want to mark the initial temperature on the number line. So I'm going to put that initial temperature right over here. Now, I want to drop the temperature of 5 degrees is like adding negative 5 to the temperature. Count on the number line to find the final temperature. So I'm going to go down 5. So go down 1, 2, 3, 4, 5. And mark the temperature now on the number line. So it's right here between negative 6 and negative 8, which is at negative 7. So what's the temperature written as an integer? Negative 7. So it's just another way to represent what's going on here with this math. A little bit of guided practice here. So I have negative 5 plus negative 1. This is going to be your negative 5, and this is your negative 1. So how many counters do you have? We'll just count them. 1, 2, 3, 4, 5, 6. 6. Do the counters represent positive or negative? Well, since they're red, we say they represent negative. Because these are, we said red was negative. So negative 5 plus negative 1, since you have 6 of them and it's negative, it's going to be negative 6. Try this one. This is your negative 2, and this is your negative 7 row. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. And they have negative counters. So negative 2 plus negative 7 is negative 9. All right, so let's model this with chips and number line. I'm giving you some options. So I have yellow's positive, red's negative. So what's negative 5 minus 2? I'm going to say negative 5. I have to do 5 of these. 2, 3, 4, 5. And for negative 2, I have to do 2. So if you have negative 5 right here and negative 2 right here, 1, 2, 3, 4, 5, 6, 7, that's going to be negative 7. I can also write this on a number line. So if I start at 0 and I start with negative 5, so I go down 1, 2, 3, 4, 5, end up here. And then I want to add negative 2 to it, so I go down 2. I'm going to end up here, which is at negative 7. All right. I'll leave you do this one at home because I've done a lot of these already. And let's do a represent a real world problem. So another one here. Jane and Sarah both drive down from the surface of the pool. Jane first dives down 5 feet, then dives down 3 more feet. Sarah first dives down 3 feet, then dives down 5 more feet. Use the number line to model this equation. So Jane and Sarah. So Jane down 5, then down 3. Sarah went down 3, then down 5. So I'm gonna do on the left-hand side, I'm gonna do Jane over here. So we start at 0, and we go down 5 feet first. So 1, 2, 3, 4, 5. And then we go down 3 feet. So we go down 1, 2, 3. And notice here we did Sarah did down 3 first. Starting at 0 goes down 1, 2, 3. And then we go down 5 feet. So it goes down 1, 2, 3, 4, 5. Notice they both end up down here at negative 8. Because negative 5 plus negative 3 is the same as negative 3 plus negative 5. Now, does the order in which you add the two integers with the same sign affect the sum? I'm going to leave that up to you to explain that. All right, another example we did. So the temperature in Jonestown and Coopersville was the same at 1 o'clock. By 2 o'clock, the temperature in Jonestown dropped 10 degrees, and the temperature in Cooperstown dropped 6 degrees. By 3 o'clock, the temperature in Jonestown dropped 8 more. Temperature in Coopersville dropped 2 more. Okay, so you have 1 o'clock, 2 o'clock, and 3 o'clock. A lot more numbers. So write an equation that models the change in the temperature in Jonestown since 1 o'clock. Okay, so you start at 1 in Jonestown. At 2 o'clock, the temperature in Jonestown dropped 10 degrees. So what we can do is say at 2 o'clock we have a negative 10 happens. And then at 3 o'clock, temperature in Jonestown dropped 8 more degrees. So we have to add more, means I'm going to add a drop of negative 8. So I dropped a little bit more. So here's an equation. Here's an expression, negative 10 plus negative 8. You add those up your way, and I'll say negative 18. So here's your equation to model that. Now do the same thing for Coopersville. If you do it for Coopersville, it goes down 6 degrees first, so negative 6. And then it goes down 2 more degrees, so plus negative 2, which is negative 8. So where was it colder at 3 o'clock, in Jonestown or Coopersville? I'm going to leave that to you to answer. All right, so going back to that essential question, sorry if it's long, given. So what's given about this problem? I'm going to look at this and I'm going to say, well, you got to look at your numbers. First, he first lost 100. Then he lost 75. Then he lost 85. So those are the things. So it's going to say lost 100, 75, and 85. And sometimes it's good to highlight that in your notes too. What is your unknown? What are you trying to find? This is what you're trying to find right here. the sum of three negative integers. That models the change in the first three terms. So we want to find the sum of three integers. So it's a sum. You're trying to find a sum. Or you can just say, I want to find the sum. What's an equation? What kind of math are you going to use? Well, you're doing sums. You're probably dealing with some negatives. And you can realize you're negative because you're talking about losing money. And losing money usually goes in the negative. Now, substitute or just set up an equation. If we have 3 times he lost money, that means he's going to get negative money 3 times, or negative points. So negative 100 is the first one. And negative 75 is the second one. And negative 85 is the third one. So here's the setup. Now we have to solve this. So if you add those numbers up, it's going to be negative 100. Notice you just add them all up first so we can put a negative sign afterward. So 100 plus 75 plus 85. And if you're doing that math, you are going to end up with negative 260 points as your answer. That's it.